So now we talk about slope convection, okay, initiated on the continental shelf in areas which are known as coastal polynyas. Okay. In this little sketch, again, you look from the side, you can see a continental shelf in a polar region. Again, there's a number of steps that you need to understand in order to understand how this process can create dense water. Okay, so the starting point is you're in an area which is very cold. Yeah, very cold. I mean, air temperatures of -30, -40 degrees Celsius, and an area where that otherwise is covered by sea ice. There's sea ice, and sea ice reflects solar radiation and blocks off and insulates the ocean. Okay, so now you need offshore winds that push the ice away from the coast and create an ice-free region called polynya. And these winds are called katabatic winds. Okay, so they push the ice away and expose the sea surface to very, very cold air. Okay, and the water is about -2 degrees Celsius, but the air can be -30 degrees or colder. Okay, and you get a large heat loss. And what it essentially does, this mechanism, is it starts to the formation of new ice, new sea ice. It's called phrasal ice. Phrasal ice is produced. Okay? This newly formed ice is also pushed offshore. So you have an export mechanism that pushes the ice offshore. So now what happens due to the buoyancy effect, that the ice, actually the ice parts of the ice phrasal, they're actually slowly rising to the surface and leaving the ice behind. They're brine channels, and this increases the salinity in the ocean and makes the water denser. This increases the salinity and hence the density. So you actually have a formation area of ice and salty water. And this is the starting point of the formation of Antarctic bottom water. And indeed, you can also see just from the sketch that there's an interaction with the atmosphere. So this mechanism also brings in new oxygen into the water, and this is a principal source of oxygen for the deepest layers in the ocean in the end.